Hello, my dear students. Welcome back to my channel RK Study Circle IIT. Today, in this video session, we are going to discuss the long answer question from functions chapter. Right here, we have the question number one. If function f is mapping from a to b and the function g is mapping from b to c, b bijections, then we are supposed to show that the function g of f mapping from a to c is a bijection, right? So in order to prove this, first of all, we have to write down what does bijection means. A particular function is said to be bijective if and only if it is both 1, 1 as well as onto, right? Therefore, this composite function g of f, which is mapping from a to c, we have to prove. For the case 1, we have to prove g of f mapping from a to c is 1, 1, and case 2, g of f mapping from a to c is onto. Therefore, as a conclusion, we mention g of f mapping from a to c is both 1, 1 and onto as well. Therefore, g of f is bijection, right? So we try to write down the same answer here. So let me start doing this question here. Function f is mapping from a to b is a bijection. Bijection. So first of all, I'm actually defining what are my bijective functions. Then later on, I'm trying to write what are the different possible cases, right? So let's say a function f of f is mapping from a to b is a bijection. Let me write, let a belongs to capital A, comma, small b belongs to capital B, such that f of a, where a is nothing but input and which is equals to b. B is your output. So basically, you are supposed to write f of a1 equals to f of a2. If and only if and only if a1 equals to a2. Therefore, we are supposed to write function f is 1, 1 function. Function f is 1, 1, right? And again, we are supposed to write f of a equals to b, right? Let me mention this one clearly. F of a equals to b. Therefore, function f is onto. Function f is onto. So I need to define the second function. G is actually mapping from b to c. B to c is a bijection. Just now I have told you what does it mean by bijection. The function must be both 1, 1 as well as onto. So in order to write this one, I am representing let let small b belongs to capital B, comma, small c belongs to capital C, such that g of input, that is b is your input and c is your output, right? So you're supposed to write g of b1 equals to g of b2. G of b1 equals to g of b2 if and only if b1 equals to b2. Therefore, this particular function G is 1, 1 in nature. Am I correct? Right. So how do you define G is onto? So function G of P equals to C. Therefore, you can say G is onto function. Onto function. So we have defined what are the bijection functions of F and G as well. So case 1, here I am writing case 1. What was that case 1? To prove the combined function g of f mapping from a to c is 1, 1. The case 1 is we have to prove g of f is 1, 1, right? So in order to prove this function is 1, 1, let me start doing this. So let me write, let a small a belongs to capital A, comma, small b belongs to capital B, and small c belongs to capital C, such that g of f, it's a composite function for which our input was A and output was C. Output value was C. So in order to say it 1, 1, we are supposed to write g of f of A1 must be equals to g of f of a2. G of f of a1 equals to g of f of a2. So for the next step, I'm going to write g of f of a1, which is equals to g of f of a2, right? So we know this function, that is b1 equals to f of a1 and b2 equals to f of a2. Let me substitute the same here. So we have got g of b1 equals to g of b2. Here I'm mentioning g is 1 function. G is actually 1 function. So what happens to the 1 when function g is 1 here we have mentioned g of b1 equals to g of b2 if and only if b1 equals to b2, then g is said to be 1 function, right? The same thing we are supposed to write here. I'm mentioning b1 equals to b2, b1 equals to b2, as well as I'm writing b1 is nothing but f of a1 and b2 is nothing but f of a2. Still we have written the same thing, f is 1 function. When f is 1 function, what we have mentioned, f of a1 equals to f of a2 if and only if a1 equals to a2. So I'm writing a1 equals to a2. Therefore, where we have started from g of f of a1, which is equals to g of f of a2, if and only if, and we are ended up with a1 equals to a2. So it was the similar to f of a1 equals to f of a2 if and only if a1 equals to a2. Therefore, we are saying function f is 1. Similarly, here also this composite function g of f mapping from a to c is 1 function. 1 function, or you can simply write it is 1, right? So case 2. Here case 2 was to prove g of f mapping from a to c is onto. We have to prove the function g of f mapping from a to c is onto. In order to prove it onto, we write the same story again. Let a belongs to capital A, comma, b belongs to capital B, and small c belongs to capital C, such that g of f of a equals to c. So we have written g of f of a equals to c. So let me write it properly. G of f of a1 equals to c. So previously we have mentioned f of a equals to b. For what? F is onto function. Here I have already defined f is onto function. F is onto function for f of a equals to b. So I'm actually writing the same thing here. Same thing here. So it will be g of b equals to c. Why? Because f of a equal to b, right? Here I am writing f of a equal to b. Therefore, g of b equals to c. And we have already defined g of b is nothing but c, where g is said to be onto function, where g is said to be onto function. So this is what g of b equal to c, in the sense you are supposed to write g of b equals to c, and that is equals to c. From here you can conclude that left hand side equals to right hand side. When left hand side equals to right hand side, what we supposed to do? The case was to prove g of f mapping from a to c was onto function. When LH is equal to RHS, then it is true that what we are supposed to prove, that has been done. Therefore, you can say, therefore, g of f mapping from a to c is onto function, onto function, right? So as a part of conclusion, what you supposed to write? What you supposed to write? From from case one and case 2. From case 1 and case 2, g of f mapping from a to c is both both 1 1 1 1